Hello, everyone. We warmly welcome you to Intel and DFI joint webinar. The topic today is DFI Edge AI solution. Hope you all can enjoy the time with us. Before we get started, we would like to bring you an attention about Intel's notice and disclaimers. Intel does not control or audit third-party data. You should consult other sources to evaluate accuracy. All product plans and roadmaps are subject to change without notice. Intel and DFI are committed to respecting human rights and avoiding complexity in human rights abuse. Intel's and DFI's products and software are intended only to be used in applications that do not pose or contribute to a violation of an internationally recognized human right. For all information, please click the Contact Intel Representative button on the webinar or your Intel representative. In session today, we will articulate from AI history to Intel OpenVINO, DFI's Edge AI solution, and DFI Intel partnership on Edge AI. Hello, everyone. My name is Linda Chen, and I am a sales account manager from Intel, responsible for IoT customers. Today, I'm happy meeting together with our valuable customer, DFI, for this webinar to talk about the real case of OpenVINO deployment and its benefits. From DFI, we have Waterbo Liu, Solution Product Manager, and we also have Sherman Chen, Intel Technical Account Manager in charge of DFI. Waterbo, could you please briefly introduce yourself?
Hello, everyone. I'm Waterbo Liu, the Solution Product Manager of DFI. Previously, I worked at Gigabyte Technology and QNAP Systems, along with comprehensive knowledge on IT technology across over 70 products. Have rich experience in product marketing and business development. Thank Intel for giving us such a precious opportunity to discuss our collaboration with Chunghwa Telecom and Intel. I will give my best shot to share my vision with you today.
Thank you, Waterbo. Looking forward. Sherman, thank you for joining us today. Can we also hear a little bit about you?
Of course, Linda. Welcome, everyone. It's an honor for me to be part of this webinar. My name is Sherman.
Thank you, Sherman. Because of the amount of data generated by IoT device continuous growth and eliminating privacy data processing at the cloud, most of AI computing is now headed to the edge. We foresee the strong need on edge AI solution. Now, I would like to pass over the time to Waterbo from DFI to bring us along with the AI journey.
Okay, so whether in medical treatment against harsh environments, industrial automation, energy, transportation, industrial computers are everywhere in our lives, but are hard to detect. So let's go to next page. Basically, industrial computer are computer systems that can withstand harsh environment and have long-term supply, such as wide temperature, wide voltage, waterproof and dustproof, anti-vibration and shock-proof, protective coating, and long-term supply. To build high-quality industrial computers also depends on long-term accumulation of experience. We have a complete solution from industrial-grade motherboards, embedded system modules, industrial-grade computers, and industrial-grade touch control computers. So, according to a research report released by TrendForce in July this year, in the first half of this year, among Taiwanese industrial computer manufacturers with a market share of more than 50% in global industrial computer market, DFI ranked third of revenue of $106.7 million and 25.2% year-over-year increase. You know, the rank in Taiwan is almost the same as in the world.
That's amazing. And I would like to also congratulate DFI. DFI is going to celebrate 40-year anniversary. 40 years is a remarkable milestone for DFI in the IPC industry. Congratulations.
Thank you, Linda.
Thank you, Waterbow. So next, Waterbow is going to brief us AI and neural network history.
Simply put, the development of AI has been more than half a century. So, but after all, across the several stages after 2010, the deep neural network have greatly improved the performance of image recognitions, bringing the third wave of AI and artificial intelligence. In the 500 million years since the trilobite development vision, the complexity of vision has increased several times. Humans discovered simple neurons in 1959. After all, the new recognition which come out in the late 1970s laid the foundation for multi-layer neural networks built in on simple neurons and the new cognitions. Convolutional neural network dominate the field of machine vision. La Net 5 in 1998 and Alex Land in 2012 are both very famous image recognition cases. The person in charge of these two projects later also worked as a chief AI scientist as leaders of Facebook and Google. So to put it simply, the convolutional neural networks are the kernels to scan image. You can think of these kernels as filters to extract different features. In short, the convolutional neural networks are the mainstream of image recognition today. Eventually, deep neural networks dramatically improve image recognition.
Thank you, Waterbow, for the sharing. OpenVINO is Intel's main machine vision development framework. Now I will hand over the time to Sherman to introduce Intel OpenVINO and Edge Software Hub.
The capability of OpenVINO covers three categories. The first one, convert and optimize model to achieve high performance for deep learning inference application. The second one, facilitate a smoother development process using the inference tools for low precision optimization and media processing and computer vision libraries. The third one, deploy your same application across different hardware engines, including CPU, GPU, and VPUs. The OpenVINO toolkit is composed of a variety of Intel tools that work together to provide a complete computer vision pipeline that is optimized on Intel architecture. And Media SDK is one of the components in this toolkit. It's a high-level API for video processing, including decode and encode. It supports H.265 and H.264 and MPEG-2 and more codecs. Video processing can be used to resize, scale, deinterlace, color conversion, denoise, sharpen, and more. The Intel Media SDK works in the background to leverage hardware acceleration on Intel architecture with optimized software fallbacks for each individual hardware platform. So developers do not need to change the code from platform to platform and can focus more on the application itself rather than hardware optimization. DL Streamer is also one of the components in OpenVINO Toolkit, which is the streaming analytics framework based on GStreamer multimedia framework for creating complex media analytics pipelines. It provides optimal pipeline interoperability and optimized inferencing across Intel architectures. CPU, GPU, and BPU, enabling implementation across cloud architecture to edge devices. And the Streamer is part of the default installation package in OpenVINO Toolkit. With the rise of artificial intelligence, the use of deep learning technology for computer vision workload has become a common application, such as image classification and object detection. Usually, you only need to send a single image into the trained model for inference to get the result. But when it comes to video file, the by-frame image analyze becomes very inefficient because if the time gap between frames is too short, the amount of displacement of objects in scenes may be too small, resulting in almost the same calculation result between frames. It's wasting computing resources and make the system too slow. Today, when the internet is developed, various applications such as smart retail, smart security, and smart city are inseparable from streaming cameras or network video transmission. With intelligent analysis tools such as the streamer, it's easier to meet the needs of a large amount of input and quickly inference. The needs for IoT edge applications have never been greater, but complex requirements, unique connectivity, security, and latency challenges are slowing down the progress and extend time to market for software developers. With the Intel Edge Software Hub, we are accelerating the development of edge computing and lowering the barrier to creating reliable, scalable applications. These one-stop resources make it easy for developers to quickly find, prototype, and integrate the edge computing software. It offers robust tools and development-ready software packages that are pre-tested and pre-validated, helping to save time and money. Simply choose the vertical-specific software package. You will speed up the solution development journey from weeks to hours.
Thank you, Sherman. After learning Intel OpenVINO and Edge Software Hub, we are also interested in knowing DFI's Edge AI solution. What about, could you share us some key highlights of your products?
Maybe audience are not so familiar with DFI. So here I must introduce the industrial computer manufacturer that has a history of 40 years. IPC products have been widely deployed in AIoT and IIoT applications in recent years due to the rise of edge computing. As such, these products have also become the key component of how repeatedly industrials can use AI technology such as machine vision. And based on long-term cooperation with Intel, DFI has established a complete industrial computer product line, covering industrial-grade motherboard system module, industrial computers, industrial tablet computers, and displays. As what I mentioned before, AI applications based on machine vision are now a major driving force for industrial computer applications. DFI also has many products at the edge AI, and there are actual success stories that can be referred to. Chunghwa Telecom's license plate recognition system is very successful OpenVINO case. This case proves the truth. Performance required from both hardware and software. As long as the software is optimized to the extreme, you naturally don't need large, improper, and expensive hardware. If you are interested in DFI's success stories, you are welcome to visit our success story website. There are already dozens of stories for your reference.
It's impressive. Thank you so much for sharing us a success story. Let's take a break for poll question number 1. Okay, poll question number 1. Have you heard about OpenVINO? A, yes, planning to implement within 6 to 12 months. B, yes, currently in evaluation stage. C, no. Let's back to the main session. After hearing DFI's HAI introduction, you might want to learn more about their solution. Let me pass the time over to Waterbowl for further elaboration about DFI and Chunghwa Telecom's AI license plate recognition solution.
Okay, thank you, Linda. As you see, it's portable system that satisfy the mobile deployment, rugged and power-saving industrial computer combined with the optimized inference model through the by Intel OpenVINO, create a solution that allow limit funds to be fall on the edge of the knife. Thanks to the DFI ES220-CS running the optimized license plate recognition software development by OpenVINO, the power consumption is only 20 watt. Chunghwa Telecom can use a general mobile power bank for power supply. This is the quotation from Chunghwa Telecom. With the help of Intel processors and OpenVINO, the combination of both software and hardware implement an extremely lightweighted inference model, simplify the complexity of hardware level. Here, we must thank Intel for promoting this case during this period, which also surprised Chunghwa Telecom. This solution brief written by Intel is also very good masterpiece, fully highlighting the advantage of DFI's industrial computers and Intel's processors and OpenVINO. So as old saying goes, seeing is believing. Let's take a look at the power of this license plate recognition system. No matter how much it's said, it's better to see it. I believe you must be surprised at the efficiency and accuracy of this system. This time, this video did not run at 4 times the speed. You can watch it longer and I will wait for you. So as for the processor utilization rate, even if the processor use the relative low-end Intel Core i3 processors, the utilization rarely exceeds 60%, which means that software optimization is very perfect. This also depends on Intel OpenVINO. It's worth mentioning that ES220CS used in this system is fanless. Please pay attention to the power consumption of the system represented by the red letters. The actual power consumption of the older machine is also very low, rarely exceeding 30 watt, so it can be directly powered by an external power bank for several hours.
Thank you, Waterbowl. We learned lots of benefits of OpenVINO. So do you have any real case benchmark data that you can share with us?
Of course, it's actually mature numbers from Chunghwa Telecom. I believe the audience must also be very curious about the real data from the actual scenario. I believe you will fear this comparison very much. The license plate detection function in Chunghwa Telecom's license plate recognition systems, the training model of which is optimized by OpenVINO, has a performance that exceeds the original 4 times. Very exciting. So also, we don't forget the existence of the graphic core inside Intel processors. The performance of the contemporary Intel's integrated graphic core has been very excellent, especially the power of FP16 can be fully utilized. Let's not forget that it's the FP16 position model that can help us get the maximum out of these GPUs. Compared to the FP32 format, FP16 models have improved the speed in terms of FLOPS, which also have to increase the throughput when used in real-time application. So most of these Intel CPU come bundled with the integrated GPU, which through is not always used to its full potential. The things change with the Intel OpenVINO toolkits. For it lets you run deep learning models on integrated GPU. Let's discover the OpenVINO performance on Intel GPU. You already know that the data transfer is also an essential part of this inference process using deep learning models. And the FP16 model provide faster data transfer than their FP32 counterparts because they require half size in the memory and only have the data need to be cached. Where using the model for inference. In actual tests, whether it's detection and the detection plus recognition, Intel's built-in graphical can achieve two times the performance of FP32 through the FP16 accuracy. So I also need to remind you that in the future, the AVX 512 instruction set will also natively support FP16 format, which will double the FP16 output rate by then. Here we take a closer look at the performance of a mass production version of Chunghwa Telecom's license plate recognition systems. You should be able to notice that the performance of this version is better than the first one. But the most important thing is that after being optimized by DL streamer, a mention had introduced by Sherman before, the performance has grown by leaps and bounds. In addition, the DL streamer have excellent multi-core optimization. Chunghwa Telecom speculates that DL streamer has better multi-core utilization, although the processor, the core 10035G4 use AVX 512 instruction set to improve the inference performance. The core 8700T has more cores than the previous one. In programs with high multi-core utilization, performance of the later will be better than the first one.
The data is very informative. And what is DFI long-term goal in Edge AI segment?
Because the development framework of Intel's 4-chip architectures will be unified into one API in the future. In the future, we will introduce the new generation of XE GPU and FPGA for deep learning and the reference learning hybrid application. DFI has established an FPGA development department and has in-depth cooperation with Intel, and it will be possible to see results in near future.
Thank you. Thank you so much for sharing the OpenVINO real case today. Let's collaborate more to bring more OpenVINO deployment together. Okay, it's about the time to wind down the webinar. It's fascinating to learn about DFI and its Edge AI solutions. Thank you, Waterbow and Sherman, with us today. We should now proceed to the Q&A session. Kindly submit your questions into Q&A box. Waterbow and his team member will be standing by to answer your questions. Okay, so there are a couple questions from the audience. The first question is, what are the obvious benefits of using Intel OpenVINO for inference tasks? So what about, are you able to answer this one?
Let me think. The complexity of the model can be greatly simplified. So the computational energy and power consumption required by the application can be reduced, and the low power processor can be used to implement the solution.
Okay, thank you, Waterville. Another question from the audience is, in addition to the processor, what other corresponding hardware platforms does OpenVINO have?
Basically, OpenVINO also covers FPGA and the rapid developing Xe family GPU.
So another following question is, so does it mean everyone can develop it once and import it on different hardware platforms?
Basically correct, and in the future, as one API matures, Intel's 4-chip architectures will be unified within a single application development framework.
Okay, thank you. Here comes another question. The question is, what are the 4-chip architectures?
According to definition by Intel, there are scalar architecture such as CPU, vector architecture such as GPU, space architecture such as FPGA, and the matrix architecture like AI chip.
Okay, thank you, Waterbow. Another question from audience is, will DFI's future product plans also adopt these 4 architectures?
Indeed, DFI has already started FPGA product planning at this stage, and everyone will see the result sooner or later.
I see. Thank you. Thank you very much for joining us today. We hope that you have benefited from today's session. The webinar will be recorded and available on demand. More information will be sent to your registered email after the webinar. For questions that we are unable to answer you today, we will get back to you via email, or you can email us at insightsalesLM@intel.com. Lastly, please complete the survey in order for you to receive the presentation material of this webinar. That's all for today's session. Join us in our future webinar. Stay safe, stay happy, take care. Bye-bye.
Bye-bye. Thank you. See you next time.
Thank you. Thank you.